Hello students, welcome back. We completed section 4. We went through the chain rule, the three-step process, and then a bunch of exercise problems. Simple problems, multiple chain rules, and then chain rule with product or quotient rule. There can be many more, and of course you're going to get many more through either WebAssign or MyMathLab. Okay, how about section 5? Here's a reminder. We are dealing with chain rule here. Now let's focus upon the second derivative computation. Calculate the derivative, and that derivative function is a function. Take the derivative of that once more. That's the second derivative function. So how do we work it out? Exponential of 3x squared minus 2x. Let's expand the font. That's the original function. And let's take the derivative. Exponential functions stay the same. Oh, I want bigger font. And then inside also stay the same. And then we have to multiply the derivative of the inside. 6x minus 2. That's the derivative of the inside. Now, if this is the end of the problem, then you can stop here. But if you want to take the derivative once more, then before that, I'd like to have some simplification. 6x minus 2 times exponential, so that a little more complicated parts comes to the right hand side. All right, we are ready. Let's take the derivative this time. Once more. So the derivative of this thing here, okay, let's stop here. That's the derivative function. And we're going to do another derivative of this. So second derivative, so double prime. And what do you have? We have a product of two functions. So this is going to be a product rule. Makes sense? We have a product. First function and the second function. So the derivative of the first function here and the second function. Okay, let's copy and paste the second function. Well, it's just single term, so I don't need the extra parentheses. And first function, no change. And the derivative of the second function. All right, here we go. All right, here, derivative of the first function was the derivative of 6x minus 2. That's easy, that's just 6. And many students will just drop this bracket and then 6 times exponential. That's fine. But here, let me keep it as a reminder that we just did a derivative computation. All right, now here, I have to take the derivative of this exponential function. So it's a chain rule again, but it's a benign chain rule. We already did it. So derivative of this turns out to be this. We already did it. So you can copy and paste, but if you forgot it, okay, in that case we have to do it again. Let's do it with this. And I'll keep the color coding red. So exponential functions stay the same. Times, oops. I have to multiply the derivative of the inside. What's the derivative of the inside? Derivative of 3x squared minus 2, that's 6x minus 2. And there goes the derivative computation, but just a little bit of simplification is in order. So 6 and then the exponential, and then 6x minus 2, and then another 6x minus 2, and then the exponential. Or you can go even further. Let's see. 6 plus this 6x minus 2 squared times exponential after factoring it out completely. And then you may want to break it up and simplify this part again, or maybe not. I don't know. If you stop at the first line, that's enough for me. But there is a reason I'm doing the second and the third step. If you have to set this one equal to 0, yes, you may have to do that later on, then factorization is necessary. If you have a factor times exponential equal to 0, then you can cross out exponential because exponential is never 0. So set this one equal to 0. What you have, you just have a quadratic equation. No problem there. But if you're doing just derivative computation, you can stop at the first line, or maybe just a little bit of simplification and stop at second line. Either way, it's going to be okay. Alright, second derivative computation. Remember the product rule, because the chain rule created the multiplication, so we end up with a product. So the second derivative rule usually begins with a product rule. Let's see, what did I do here? Yeah, we got that. And then we use the product rule. The second derivative requires a product rule as well as a chain rule because we ended up with a product from the previous chain rule. Now, most of the time you're going to have to do those product rule, but here's an exception. Let's calculate the derivative of this logarithmic function. What is derivative of log? Derivative of log of x is 1 over x. Derivative of log of y is 1 over y. Derivative of log of t is 1 over t, etc. So 1 over whatever that's inside. 4th power plus 3y squared. And then I have to multiply the derivative of the inside. Let me expand the font a little bit. Make sense? Outer function is logarithm. So 1 over whatever, and whatever it is inside stay the same. You see, inside never changes. So this 1 over that fraction that part is the derivative of the outer function logarithm, and inside never changes. And then we have to multiply the derivative of the inside. What's the derivative of inside? 4y cubed plus 6y. Did I do this right? That's the derivative of the inside. Normally this would have been it, but that's not the end of the problem here because we have to do the second derivative computation. So first derivative here, and we need to do some simplification in order to do the second derivative computation a little bit more effectively. So what do? This multiplication times this fraction applies to the numerator. So we get this, 4y to the 3rd power plus 6y over y to the 4th power plus 3y squared. So whatever inside goes to denominator, and the numerator is the derivative of the inside. Okay, the derivative computation is done. Now let's go ahead with the second derivative computation. So what do we have here? We have a quotient rule. So let's go ahead with the second derivative computation. From this quotient, denominator squared, and then in the numerator we have u prime v minus uv prime. That's the structure. So u prime and then v, well, that's the denominator. So here we have the denominator. And then uv, so the numerator. Okay, and then we have to fill out these derivatives. U prime, v prime here. Okay, u prime, what's the derivative of the numerator? 4y cubed, so that's 12y to the second power plus 6. Did I get the derivative computation correctly? Next, v prime. So what do we have here? 4y to the third power plus 6y. Oops. So that's the derivative computation of the denominator here. Let's see. Highlighted in brown and purple respectively. So the numerator here, and then denominator here with color coding, brown and purple, and then just copying, I just use black, the derivative computation for the numerator, brown, the derivative computation for the denominator, purple. So log function turns into a fraction, and then the second derivative turns into a quotient rule. That's pretty typical. Otherwise, second derivative computation typically brings about the product rule because the chain rule gives you a product in the end. So what do we have here? Yes, the same thing. Yes, the same thing. Okay, do you have some time for trig functions? Okay. No, not enough time. Let's stop here. We went through the second derivatives, applying chain rule, and then either product or quotient rule with chain rule. A lot of chain rule in the end.